Hello, this is going to be a tutorial about how to use Autodesk Inventor release 2016 and how to use Ansys release 15. Okay, the idea of this video is to try to make geometry here in Inventor and export that geometry to Ansys and simulate flow through that geometry. Okay, so let's start with how to create a geometry here. First, we have that when you first start Inventor, this is what appears in your screens. So you made a new, and you can choose the templates if you wanna work in inches or if you wanna work in millimeters. I choose a standard IPT in millimeters. So I have it here, and we could identify some features of this program. First, we have this panel. And this panel records what did you do? What do you do? I'm sorry. My English is not very well. I will try to do my best with that. This panel records what do you do while you're working. So if you want to modify something or edit something, you come here and edit the object you will create it. It keeps a record historically created, so um, uh, will record everything you do in an historical way. It's something like a line timeline. Okay, so we are going to create a circle in the XZ plane. I have to clarify that first some comments. Um, with the wheel of your mouse, you can do zoom in or zoom out. Zoom in, zoom out, as I'm doing right now. If you press the wheel, you can move the object or the screen parallel to screen. And if you press also shift and keep your wheel pressed, you can do this. You cannot see very well, but if you see this cube here, you can see how the cube is moving. I will experience more with this later. Okay, so we are select the XZ plane and create a we are going to start a new sketch in 2 dimensions. We are going to start a circle and in the XZ plane. Okay, while you're creating the circle, you can edit the dimensions. So I'm going to put 1000 millimeters. That is actually a meter. Um, so we have here a circle of 1 meter of diameter, not radius, diameter. Okay, and if you can see object called sketch 5, it has been created on this file. So I could save this one in sketch mode. I'm sorry, I have to finish the sketch first. And if I go to the ZY plane and go to the bottom, there is my. So when you create a sketch, you have to select a plane first, and a sketch in 2 dimensions has been created on that plane. Okay, now I could save this one. I will save it on desktop. I'm going to call it pipe. Pipe example, and save it. Then I could do some things with this one. In the 3D model we could extrude this geometry, and with extruded we could create a new solid. Here is this is the icon for create a new solid. We select the profile. The profile is already selected, and now we could choose how much do we want to extrude it. Okay, and the direction for that. I want to extrude it in the direction of the screen. Okay, so I do okay, and now if we press shift on the wheel and move the mouse, we could do this. Okay, so as you can see, I'm going to press and the plane is there. I want it in the other direction, actually, as I could say so. I could edit the feature and put in the other direction, and now is in the direction I wanted. So let's do it. Okay, let's select again the plane except, and let's create another sketch. Okay, so I'm going to start with a rectangle. I'm going to select a rectangle 2-point center and zoom in on center, and I'm going to give 60 centimeters by side. 60 centimeters by side, and I finish this sketch. Now I'm going to create another plane. I'm going to use this feature one, a plane. I will use an offset from plane, and I'm going to choose the plane except. This is the plane we am going to create another plane from this plane using an offset. So I'm going to put the 6 meters. What is 6,000 millimeters, but I want it in the other direction, so I'm going to put a minus. Okay, so enter. And as you can see, I have created our work plane here in the list in this panel, in the other panel, and I'm going to select this work plane and then create another sketch. Okay, and I'm going to create another rectangle. This occasion is going to be a 2 object, so a 2-point rectangle. I'm going to input the measures, 300 millimeters and 300 millimeters. If I move for that panel, I'm going to create another object. For example, I cannot modify this by modifying this one. For example, I'm going to delete this one, this thing, and if I want to modify the sketch, I could modify the measure, but I cannot put minus 300 because that's not going to make my square to rotate to the other side, so that is not possible. Okay, I'm going to put that. Okay, and now I'm going to draw a line from this point to this point. From that, first I have to do another plane. I will do a plane based on this line here. How do I do that? I choose that one, I choose that, and that's another thing. And okay, bye-bye. And here's my plane. If I see from bottom, there's a plane that cross that point and the other point. So I'm going to do a zoom out, move this to this, and I'm going to draw a line. Okay, I'm going to draw I'm going to start a new sketch. I'm going to start a new two-dimensional sketch line. From that line, from that point, oh my gosh. So I'm going to draw from this point to that point a line. I think I could do this. I'm sorry. I didn't select the plane, so I finished the sketch. I'm going to select the plane, select the line. So now I'm going to move and select the point. Da, 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 da. I'm going to do it for the center, okay? I'm going to do another thing, okay? I'm going to cancel this. I'm going to delete this sketch. This sketch. Okay, I'm going to first finish the sketch. Sketch H was not a sketch, so I'm going to delete it. And sketch 7, I'm going to delete it too. Sorry. So I'm going to create a new sketch, a rectangle, but a 2-point center. Click bottom, click the plane, work plane 2, and now I'm going to create in 50-15. That point. And now I'm going to select the side of the side. 300 millimeters and 300 millimeters and that. Okay, so finish the sketch, and now I'm going to create the line in the plane 3. From this point to this point. Okay. Look that actually the object is in the plane. I wanted a plane here. I don't want this. Finish the sketch. I want a line from this middle point to that middle point. So the plane I created, the work plane 3, is not right. So I'm going to delete it. If I choose this one, I'm going to delete the sketch. So I'm going to delete the sketch, okay? And also in the sketch 10 it was erased. So I'm going to create a line here. I'm going to create a plane from this line, and I'm going to choose that, and I have already created a plane that crosses from that and crosses from that plane. So if I choose the bottom, you can see I have created a plane that crosses from this and crosses from that. Okay, so now I select that plane, start new sketch, select line, select that point, zoom out, zoom in, not zoom in, and select that point, and select that point. Bah. Okay, finish the sketch. Finish the sketch, and now I'm going to do a loft. I could do a sweep or a loft. It's almost the same. Okay, but the sweep keeps the area constant. So what area? For example, if a sweep draws a pipe across a geometry, for example, I keep this area and I draw a line like this, and so it's I don't know how to say it, but it projects this area across that line. Okay, but the area keeps constant, you know, on the line. A loft, in the other hand, let me to draw a volume from from different areas, from a sketch from different areas. So now I'm gonna do that. I select the sketch 6 loft. I select this one. I select the sections, and I select the sketch 6. No, center line is the sketch 11. Yeah, that is what I wanted. I select this as the same solid. If I want another solid, I select this one. But as I'm working in the same solid, I select this one. Okay? So I select the center line and click for add a section. I select that, and I wanted to select this one. I select it here. Okay, and I have already. That is what I wanted to do. So now I'm going to make it invisible and hide it both planes. And now I have a geometry. I'm going to simulate a flow through this geometry from this as an inlet and to this one as an outlet. And also I wanted to make this, if I fillet, if I made a fillet, I could do this thing. 2 millimeters is okay. No, not 2 millimeters. I want to edit that feature. make 200 millimeters. Okay. Oh, it failures. Maybe 90 millimeters, maybe 100, 150 millimeters, and that happened. Okay. Um, it's okay for me. Good enough. Save it. And now we could close Inventor. Okay. So right now, what are we going to do is to start a new our project in Fluent. For that, we select Fluid Flow Fluent. We 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 copy that to our project schematic and appears that one. So in geometry, we made it double click, and another window will appear. Okay, we have to wait a little. A little more. Ansys take its time. Okay, and this is the workbench. This is where you create a geometry in Ansys, but we are not going to create the geometry. We are going to import the geometry. So for that, what we are going to do is go to File, Import External Geometry File, and we are going to choose our geometry we created recently. By example, okay. The geometry is not created until you generate it. For that, first we have to here in Mix Import Resolution put a solid or a surface in the case of you are going to import a surface, but as we are going to import a solid, you have to in Mix Import Resolution put a solid. If you don't do that, maybe you will have problems importing that geometry. So generate it. As always, Ansys takes its time. And now should appear the geometry. Here above we could see the progress, and that is geometry. Okay, and that is a geometry. Here in Ansys, Chief is almost the same as Inventor. When you want to do a translation, zoom in, zoom out. The only difference is you do with Control key, not with Shift key. So if I want to do a zoom in, zoom out, is the same with the wheel. If I press the wheel, I do this thing and if I wanted to move parallel to this plane, I press Control and I move like this. So okay. First thing you have to do here is name the areas. Okay, I'm going to name this as name selection, and I'm going to select it as name it here as an inlet. Okay, and generate. Also, I'm going to name the outlet. This is going to be the outlet. Selected, name selection. Okay, generate, and name all the others as as wall. Okay, I keep the key control pressed while I'm doing this. So I have been selected all other surface, and I'm going to name them, sorry, as a wall. This is a very important step. What happened? Something's happening. It doesn't show me. Oh, the name selection. And now I'm going to name it as wall and generate. So I have named the inlet, the outlet, and the wall. So we are ready for save this as a workbench project. I'm going to save it in the desktop, and I'm going to save it as a pipe example. Pipe example. Okay, so that is how I made a geometry. The geometry right now is okay. The next step is to build the mesh. Okay, so I may double click on mesh. For this step, it's crucial to have had the inlet, the wall, and the outlet named on the geometry. And with that names, yes, you have to be very accurate with the names. You can't name it name the surface as you want it. It's very is very uh, you have to do it that way. Okay, so you do generate mesh. Okay, the mesh is going to be generated, and it has been already generated. Okay, you generate with this button. I did it, generate mesh, and if you select the mesh, you can see it. This is the mesh. Okay, you can select the size in here. You can select the sizing. You can select the assembly inflation. What is inflation? Inflation is some kind of mesh defining on the on narrow places, on not narrow places, on the corners of the geometry. Okay, I'm not going to use inflation because I don't need it, but I want a very fine a very fine uh, mesh. So in smoothing, I say I say I'm sorry. I say transition slow. Slow is fine. Relative center, fine. And I'm going to regenerate it. Okay, and that here I have a good mesh right now. Okay, so I could save project and close this one. Okay, I'm gonna close it, and I'm gonna close the window of the geometry. Okay, now I have to update it. Yeah, that brings our mesh to our project X schematic in Ansys. If we did all right, we will not have any problems, and actually we didn't. We don't have problems. Next, we are going to set up our computer for made calculations. I'm going to do double precision, parallel processing options. I choose 2 and 2. Okay, what this has to be with the number of processors um, that your computer has. Okay, or how many processes a computer can run. I understand that. Okay. If it's not, I have to say sorry. But yeah, I understand that this is the quantity of processes a machine can run in parallel, and how many processors per machine can use for that purpose. As you know, some processors have more than one sub-processors or nucleus. So this refers to the number of nucleus you use. I don't know how to say nucleus in English, but I suppose it says that. So I made OK here. OK. And then the solution windows will open. And this, the solution windows, is initiated. We have to set up some parameters before we could simulate the flow. I'm going to simulate a airflow with some parameters. As you can see, as I define an inlet and an outlet, the program itself identified that automatically. I have no problems identifying which is a wall, which is a wall, which is an outlet, and which is an inlet. The program itself identified itself. So in meshing, I have the mesh in solution stop in general. Here in general, as I'm going to simulate airflow, I'm going to use a velocity formulation, pressure based, steady, no transient, because I don't care about the transient. I'm going to simulate steady. If you know what is this steady, it refers when some time has been passed since the zero time, and transient is about the first moment of your simulation. Okay. Here you can change the scale. I'm not going to do that. You can change the unit. I will change meters, close. And also in units, you can change that. You see acceleration, also meter per second, area. For example, one measure that is interesting to measure is pressure. And pressure is in Pascal. You can choose in atmosphere, PSI, and liters per feet, inches of water. Inches of water, I think it's used on medical applications, but I'm not going to do that. I'm going to choose pascals. Okay. So you press when you are ready, having choosing your units, you press list. Okay. And close. About the gravity, I want an acceleration in, as you can see here, you have an axis. I want acceleration in e-axis. Okay. So I put 9.8 meters per second in the e-axis. So this is like a chime. Okay. And enter. And models. And here we are going to simulate a viscous laminar. When, if you want to if you want to simulate a laminar flow or a turbulent flow, you can use k epsilon, k omega, Reynolds stress, transition SST. The most detailed model for a turbulent flow is large eddy simulation, but with k omega is good enough for us. So I'm going to simulate ESTT. Turbulent viscosity, none. All is good. Okay. So in materials, fluid is air. I can change the material fluid. I could choose another thing. For example, I could choose solid or fluid. I could choose fluid material. If I don't know that, I could use another fluid. For example, water. Okay. I have to do water vapor. Let's simulate water vapor. Okay, it's more interesting. Copy, close. So now we have water vapor instead of air, and close. And the solid is going to be aluminium. Okay, aluminium is well enough. And the sexual conditions. The pipe example IPT, that is a solid we created on Inventor, is going to be the fluid or the fluid area. I'm going to simulate just the fluid area, not what it happens with the solid or with the walls. So in this is going to be the fluid. I could edit here, laminar zone, blah 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 blah. I don't care about that, so let's click OK. On boundary condition, this is very important. Okay, I could use conditions of velocity inlet or change that to pressure inlet. Let's say yes. I choose this one when I know the conditions. For example, if I know pressure conditions here, I use pressure inlet. If I know pressure conditions here, I know pressure outlet. If I know, for example, I select outlet, I select outlet band, pressure outlet. I'm going to use velocity outlet. No, there is no velocity outlet. I'm going to use pressure outlet, and I'm going to use gauge pressure. So I'm going to say 0 because I'm going to assume that the outlet has atmospherical pressure. Okay. I'm going to change that to k omega. I'm going to say OK. The interior, if I say edit, it shows me nothing. If I say wall, the wall shows me nothing, and I could choose the motion of the wall. I will say stationary wall and no slip condition. That is very similar to laminar fluid. Okay, so next, what I'm forgetting is the inlet. I'm going to choose a velocity inlet or a pressure inlet. It's more interesting, pressure inlet. I'm going to set this for 1 million Pascal, 10 millions I think, yeah, 10 millions Pascal, that 10,000 kilopascal. And I'm going to assume not supersonic k omega, and OK. Next, the dynamic mesh. It's not going to be. I'm not going to use these options. In reference, I will compute the iterations based on inlet. Okay. And then in solutions, I'm going to use a couple. This one, keep it just like that. And monitors, solution initialization, standard initialization. I have tested both, but the standard initialization is more suitable for our purposes. Okay, so compute from inlet and initialize is very important step. Okay. Okay. And calculation activities, nothing else, and run calculation. And this one, you have to set the number of iterations. I'm going to set it in 100. Calculate it. Okay, calculate it, and start. We have to wait a little. This it shows the residuals of the problem. The idea of the residuals is the residuals have to be small as possible. We're on the half on the calculating solution. And also we arrived to the solution. The residuals made it itself very small, and now we have a solution. So let's say, okay, for see the solution, we go to results, graphics and animations. If you want to see, for example, velocity vectors or pressure contours, you have contours here, or vectors. Okay. I will show you the pressure contours set up across a plane, and you have to define a plane. Foresee the contours. Okay. So if I go to the geometry, I will make click here. Wait a little, please. Okay. We wanted to see what happened in this plane. So that plane is the set plane. Okay, so it's the XY plane. So I wanted to see what happened in the XY plane. So I go to Fluent and I'm going to create a XY plane. Okay, so click on New Surface, Plane, and I'm going to create a plane up from a point and normal. The point is going to be 0, 0, 0, 0, and 0, and the plane is going to be the XY. So I have to put a 1 in set. Okay, and I'm going to put it XY and create, close. So I choose that plane, I put fill, and I choose the levels. You have to 100, from 0 to 100 levels for display. I'm going to display that, and that it shows me the contours of pressure, or pressure contours, excuse me. I'm going to close this, and I'm going to use that. I don't like this one. I wanted to see it from right to left, from left to right. So in views, I choose camera, and I could change this, the angle. And that. apply, close, close. And now I could make a zoom with this one, and now you can read the pressure. Also you have here 10,000 kilopascal here, and here you have the atmospheric pressure, and you could see the distribution of pressure contours, the distribution of pressure inside the pipe. Okay, and the velocity, how you see that? We could see vectors of velocity. You could choose the measure you want to see. Velocity, colored by velocity, pressure, density, blah 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 blah. Velocity, you want to choose velocity magnitude, x velocity, y velocity, x, z velocity. I want to velocity magnitude, and I want an arrow in the and I want a fill arrow. That is the end of the line. Okay, I want a scale of 2, no 1, or 1-on-1 scale display, and that you have the velocity vectors. Okay, as you can see, the velocity is greater here and very slowly here. Okay, close. With this button I could move from here to here. Oh no, I see that. If I want, for example, some pressure measures or velocity measures on the inlet or in the outlet, I could use it on reports. Okay, for that in graphics and animation I must create another plane. For example, I must create a plane here. Where do I want it to calculate the pressure? Or here I must create a plane if I want the pressure in the inlet, or sorry, in the inlet here, or in the outlet here, or here if I want in this point. Okay, I'm going to create a surface here, or I don't know, new surface, plane in the x in 0 0 0, but in the here and here 0, and that is going to be my plane x set. Okay, create, close, so close. And now when I'm going to, if I go to reports, I'm going to surface integrals. I choose the xz plane, and if I set the area and compute, as you can see, the software delivers the measure of that area. Here, the area of the cut xz plane on the volume. Okay, if I wanted integral, a pressure surface integral, I go to air weight average pressure, compute, and in that volume I have that is the amount of Pascal, the average integral, average area weighted average pressure surface integral. Okay, so where is that area? Let's see where it is. If I'm going to graphics and animation, on contours, setup, I choose that area, both area, display, And now I move. Sorry. I I move. I choose that. Oh, I'm sorry. Press this one if you if you if you commit an error. You can fix it with pressing that button and moves the view to a suitable view. I'm going to press that, and that is the surface. So the exit surface is in the middle. Okay, as you can see. If I just wanted to see just that, I display just that, and that is in the middle. Okay, so what I'm calculating here is the area weighted average static pressure on Pascal in that surface. Okay, if I wanted to do the same in the inlet or in the outlet, I have to define a point in the inlet and set an X set plane in the outlet or in the inlet, or and define a point in the outlet and define a X set plane in the outlet. Okay, if I want, for example, the velocity, the volume, the average velocity, I go to area weighted average pressure. I choose velocity, compute, and that is the value. 1000, almost 1000 meters by second. Okay, and that has been my tutorial. I hope you like it. Have to say sorry for my bad English. It's not the best English, but it's what I have. And that's all. Thanks for watching.